Okay, so for target 4, solving systems of equations, this is focused on 3-variable solving, so not 2-variable, 3-variable. Keep in mind that 3-variable solving is a little bit more challenging. It requires a little bit more work to get to a point where you can actually solve. But we use the same method that we would have used in 2-target or 2-variable systems, which is elimination. So your systems will look something like this. First of all, the first thing you want to look for is to make sure that your x's, your y's, your z's, and your constants and your equal signs are all kind of lined up. So you'll note that that's how these are organized right now. Now, I always like to label my equations. I find that to be the most effective way to deal with this. So I'm going to call this equation A, equation B, and equation C. Once I get to that point, I start to look at, okay, which letter is going to be the most efficient for me to cancel out? Generally, with these types of equations, all of them are going to be fairly equally easy or difficult, and it's up to you which one you want to work with. Me looking at this list, I'm going to choose to eliminate x's. My reasoning is because 2 numbers are already the same, and the last number is a 1, which means that when I have to multiply to do my elimination, it's a little bit easier. So I'm going to combine A and B, and I'm going to combine B and C. Now, the way that I always tend to do this is I tend to make one number the positive and one number the negative of the same value. So like these are both negative 4s. I'm going to want one of them to be a positive 4 and one to be a negative 4. So in order to do that, I need to multiply one of my equations by a negative 1 to turn the value into a positive. So I'm going to multiply this C equation by negative 1 when I bring it over here. So it becomes positive 4x, positive 4y, positive 6z, and a negative 28. So I just took each of my values and multiplied them all by negative 1. Then I'm going to leave my B equation exactly how it was, no changes whatsoever. Now that I have done that, I can add my equation together. So when I add the x's, cancel, which is our goal. Elimination is to eliminate a value. So when I do this, I end up with 3y's, because negative y plus 4y is 3y, 5z, and then over here I get negative 9. Now for my A and B equations, I'm going to multiply my top equation by 4 to make this a positive 4x. So make a note of that for myself. So I have 4x minus 8y plus 24z equals 8. And then my bottom value is going to be negative 4y, or 4x, I'm sorry, minus y, minus z equals 19. Then I can go through and add. So these will eliminate. This will be negative 9y, this will be 23z, and this will be 27. So by doing this, I now have created 2 equations in 2 variables. And notice the variables are the same, which makes this into what we did in Algebra 1. So once I've done that elimination, now I can create a new system of what I've got left. Okay, now check the main office, or the office over there. Now I have these 2 equations in 2 variables, so I've lined everything up just like we did in the beginning. Now, looking at these, I have to make a decision. Do I want to try and eliminate y's or z's? I generally look for the pair that appears to be the closest together and the easiest to work with. So, is it going to be easier to turn a 5 into a 23 or a 3 into a 9? 3 into a 9 is probably easier. Now, since this is already a negative 9, I want this one to be a positive 9. So I only need to multiply by 3 to make that happen. So I'm going to multiply that equation by 3. And I'm going to leave my other equation alone. No changes whatsoever. Now when I do my adding, the y's cancel. I'm left with 38z and 0, which means that z equals 0. So now that I've gotten that far, I need to go back in and plug those values back in to find my other values. So I've gotten z, now I need to get y. So I'm going to plug z into either this equation or this equation. It's completely up to you which one you want to use. I generally pick the one that looks a little bit easier. So for me, this purple one seems easier. So I'm going to say 3y plus 5 times 0, because we said z is 0, equals negative 9. So 3y equals negative 9, because 5 times 0 is just 0. And I can solve that to find y to be negative 3. Now that I've got those two values, I can go back to one of my printed equations at the top of the page and find my x value, because that's the only one we're missing. So I'm going to use the top equation because that looks the easiest. So x minus 2 times negative 3, because we said y was negative 3, plus 6 times 0, because we said z was 0, equals 2. So I have x plus 6 plus 0 equals 2, or x plus 6 is 2, which means x is negative 4. So my final solution is written as a 3-piece coordinate, so the x value always goes first, y value always goes second, and the z value always goes last, so like in alphabetical order. Oof. There we go. So that would be the solution to your system. Okay, so new system for you here. So whenever we're looking at the system, you could solve this a zillion different ways. It does not matter which one you prefer. I always look for the letters that are the smallest. So like my first thing to look for is if I have anything that are the same. So like I see that I have a z that is positive 5 and negative 5. So that's convenient. And then I look at the third option. So is there an easy way to make 4 into 5? Not really, but they have a common multiple that would be easy to work with of 20. So that's an option. The second thing I look for, if I only see a pair and it doesn't seem like it would be super easy to work with, is values where the coefficient is 1, like it is here. I also notice that these numbers are really small. So in this case, it looks like it might be easier to work with x than anything else. Does that mean you couldn't do this with other values? Absolutely not. All right, so if we're going to eliminate x's, I'm going to label my equations a, b, and c. I'm going to combine a with each of them because it's going to be easiest to multiply a by things to get the other values. So I'm going to do a and b and a and c. Now in order to get the same value but opposites, this is a negative 3, so I'm going to have to multiply a by a positive 3 here, giving me 3x minus 12y minus 15z equals negative 15. B is going to stay the same. And then I'm ready to add. So when I do that adding, x's cancel. I'm left with negative 15y minus 19z equals negative 42. For my second one, in order to make this into a positive 2 so that those match, I need to multiply this equation by 2. So I get 2x minus 8y minus 10z equals negative 10. And the bottom equation stays the same. And I can add, my x's cancel. This becomes a negative 3y and a negative 5z. So I've got my two equations in two variables. Again, notice they share the same variables, y and z. So we eliminate the same thing in both sets when we're doing this. So I always like to just take a moment and write my equations next to each other because it makes it a little bit easier for me to see what I'm doing next. Not everybody likes to do this step though. It also allows me to just kind of make sure that my handwriting is neat and tidy and it's easy to figure out where I'm going from here. You'll also notice that I tend to write little lines through my z's because otherwise they start to look like 2's. So you'll see me put like a little line like that. Now we have to eliminate again. So is it going to be easier to make a 3 into a 15 or a 5 into a 19? Totally up to you which way you want to go. I think the y's will be easier here because I can think of what I need to multiply 3 by to make 15, which would be 5. Now, since this is already a negative 15, I want to make this a positive 15, which means I'm going to multiply by negative 5. And then I'm ready to add. So when I do, my y's cancel. I'm left with 6 z's and 8t, which means that z must be 3. So we do kind of 3 sets of elimination to get one letter. Once we have one letter, we kind of work our way back upwards again. So we're going to take that letter and plug it into one of our 2 variable equations, whichever one you feel more comfortable with. So for me, I think that the top one is a little bit easier to work with. So when I do that, I get negative 3y minus 15 equals negative 12. Negative 3y equals 3, which means y is negative 1. And then now that we've got 2 letters, we can go back to our original equation. I think the top one is a little easier to work with. So I would go x minus 4 times negative 1 minus 5 times 3 equals negative 5, which gives me x plus 4 minus 15 equals negative 5, or x minus 11 is negative 5, which means that x is 6. So my final answer is 6, negative 1, 3. So when you're done, make sure you write your systems as a 3-coordinate pair or however you're asked to write it.